Hello, my name is Bob DeHilster and I am your particle model guru. I will explain the universe using the particle model. Particle model has three main particles. It has a nucleon, which replaces the proton and the neutron. It has the G1 particle, which replaces the electron, the photon, and the graviton. And it has the G2 particle, which is responsible for the nuclear binding force and is often similar to the electric field commonly talked about. Today I'm going to talk about the fact that the particle model is a mechanical model that basically causes motion due to a push, not a pull. So we're going to really try to describe the fact that pulls in physics don't really occur. In our common language, when I take a cup, like this cup, and I pull it towards myself, it's called a pull. When I push it away, it's called a push. I'm going to show you why when I pull the cup towards me, I'm actually pushing. So the first part of the test, I'm just going to use this cup. I'm going to take my fingers off of the back of the cup, and my thumb is on the front of the cup, between me and the cup, and I'm going to pull it. Well, clearly, the thumb is not going to move the cup. It's going to stay where it's at. Put my fingers back behind the cup, remove my thumb. Now I'm going to pull the cup towards me. But notice my fingers are actually behind the cup pushing. I'm not pulling the cup. My fingers are behind the cup pushing. Now suppose that I do the same thing, only this time I'm going to do it much faster. I'm going to pull much faster. I'm going to have the cup just sitting flat on my hand. Now I'm going to pull it fast. And as you see, it falls over. You pull it too fast without the thumb, it falls over. So now I'm going to put my thumb back on the cup, and I'm going to push it real fast. Doesn't fall over. Why? Because my thumb is pushing the cup against my fingers. The fingers are moving the cup by pushing it towards me. The thumb is stabilizing the cup so it won't fall over. This is a push, this is a push, yet we call it a pull. In physics, it's a push. Another example, this is a clothesline. I'm going to hold the clothesline out here, and then I'm going to grab it and pull it with my left hand. I'm pulling with this hand. I'm holding it like a wall with this one. Now clearly that has to be a pull. My fingers are not behind the cord, but in one sense it is. If you look at the cord real closely, if you can see it, the cord, it's hard to see, has, as you well know, a lot of threads of some fiber woven together to make the cord. Now, what really happens is, if you visualize my hand as the cord, okay, if you visualize my hand as the cord, and these are the strands in the cord, and my hand is my hand, but it really represents the skin. When you push against, when you squeeze the cord, you're pushing your skin into the crevices of that cord. And so if I remove all of them, if I want to, I'm going to turn it this way. If I'm going to pull the cord towards me, I'm going to use my right hand to pull it to the left hand towards me. What I'm actually doing is the flesh behind the strand of the cord is behind it, pushing it, even though I call it a pull. So even this way, it's the pull is a physical push. Maybe harder to understand. I have a challenge for you. Find a motion where you call it a pull and try to describe it without having to, and try to describe it where you can't describe it as a push. It has to somehow be a pull. And you bring it to my attention and we'll discuss it. That's your challenge. Well, this is Bob D. Hilster. I'm your particle guru, and you can tune in the next time to hear more about the particle model and how it explains the universe. Thank you.